This tutorial is all about explaining how to give an expanded numeral for a decimal number that's expressed in the compact form. So we have here all compact numerals, 12.092, 0.859, and 954.6184. So let's have a go. One of the ways that we can think about all of these problems is to use a diagram that's similar to this, just to help us along a little bit and think about where all the numbers, all the digits need to go and their relative place values. So let's deal with number one, for example. So number one, here if we look at these little houses, if you like, these here are all the periods, okay? And periods help us understand the place value a little bit better as well. So this here would be our ones, this here is our tens, this here is our hundreds, and we repeat that here. So ones, tens, hundreds. The only difference here in the thousands period is that these are the hundreds of thousands, these are the tens of thousands, and these are the ones of thousands. The only difference is we don't really say ones of thousands. These are the hundreds of ones, the tens of ones, and the ones of ones. But again, we don't say the ones, okay? We just say hundreds, tens, and ones, and we know what we're talking about. It gets a little bit tricky when we're dealing with decimals, because where does the decimal point go in this diagram? Well, a lot of diagrams will have the decimal point going here, and that's fine, but that means that this place value, if you like, remains empty. So you can either think of it like that, or put the place value, put the decimal point, sorry, right here. Okay, and these place values kind of go in reverse. The oneths of oneths, the tenths, and the hundredths. The ones of tenths, the 100th. Okay, and then this keeps going. So tenths, and then hundredths. The ones of thousandths. Okay, we don't need the ones. We don't usually say it. The tens of thousandths and the hundreds of thousandths, that all works. Okay, so this oneth, there is no oneth. Okay, it gets replaced by the decimal point. And now, when I put the digits in, it starts to make a little bit of sense. So the 12, so the 2 is in the ones, and the 1 is in the tens. The 0 is in the tenths. The 9 is in the hundredths. And the 2 is in the ones of thousandths, or the thousandths column. Okay, now we can have a quick look and take a look at face value and place value, because that will help us with solving this problem of giving the expanded numeral. So if we take this 1, I'm just going to do it over here. What this 1 really means, the face value is 1, just what it is by looking at it, right? The place value, so I'm going to multiply by its place value, is tens, so that's a 10. Okay, and then I'm going to add the 2, so that's the face value of the 2 is 2, just the face value is what it is when you look at it, and I want to multiply by the place value, which is 1. So if you look here, this is the face value, and I'm multiplying by the place value. Face value, multiplying by the place value, and I'll just keep going. So I'm up to here now. I've got 0. I could go 0. I could go like this: 0 times 0.1, because that's the same as a tenth. So 0.1 is the same as 1/10, which is the tenths. But why include it? It's going to be 0. So yeah, while you can include that, I won't. I just skip that. I go to the next one. So it's 9, the face value is 9, multiplied by its place value, and this is the hundredths, so 100th, right, which is the same as saying this, so multiply by 0.01, okay, and then up to the 2 is the face value times the place value, and here you can see I'm in the thousandth period, so it's the thousandths, and can look like that, the ones of thousandth, and it looks like this is a decimal, 0.001. And you can see here that however many zeros there are in the fraction, that's how many decimal places there are in the decimal version or the decimal form. So there are 2 zeros, so 2 decimal places. 3 zeros, 3 decimal places. Okay, so it'll be 2 times 0.001. Okay, and then if I simplify these, so this is going to be, so that is one version, that is one way you can write the expanded version. And the other way is you can simplify all of these brackets. So you can have 10 plus 2 times 1 is 2 plus 9 times 1 is 9. So it'll be 0.09 plus 2 times 1 is 2. So it's going to be 0.00. And then 2 times 1 is 2. And this is another way of giving the expanded numeral. That is number 1 done. Either this answer or both. We're ready for number 2, and it's 0.859. So 0.859. So should be relatively simple. Let's have a look. Again, let's do the expanded version. So we start with the face value, which is 8, whatever the digit is, just looking at it, multiplied by its place value. Place value is the tenths, so again, 0.1. Plus, next one is 5, face value, multiplied by its place value, which is the hundredths, so 0.01, plus 9 times, this is the thousandths, so that's this, so it's 0.001. So that's one way you could give the expanded numeral. The other way is to just multiply out of these brackets. So we go, this is one way, this is the other way. It'll be 0 point, and then 8 times 1 is 8. Plus, it'll be 0.0, and then 5 times 1, 5. Plus, it'll be 0.00, and then 9 times 1 is 9. And that's the other way you could give the expanded numeral. Okay, let's have a go at number 3. So 954.6184. So let's go. This will take a while because there's a lot to write down. So it'll be 9 face value times its place value, which is 100, plus 5 times place value of 10, plus 4 times place value of 1, plus 6 times place value of tenths, so that's 0.1, plus 1 times its place value of hundredths, so 0.01, plus 8 times 1,000th, so it'll be 0.001, plus, right, what is it, 4 times tens of thousandths, so 10,000th, so that'll be 0.0001. 0.0001. Okay, so that is one way to express the numeral as an expanded numeral. And so that's one way, and that's fine. And now I want to try and squeeze in down the bottom here the more compact expanded version, if you like. So 900 plus 5 times 10 is 50, plus 4 times 1 is 4, plus it'll be 0 point, and then 6 times 1 is 6, plus 0.0, and then 1 times 1 is 1, plus it'll be 0.00, 0.00, and then 8 times 1 is 8, plus 0.000, and then 4 times 1 is 4. And that is the other way you can give an expanded numeral. And that's done.